Welcome to educator.com. This lesson is about solving equations with variables on both sides. In this lesson, you will learn to solve equations with variables on both sides. And you will do this by bringing all the variable terms to one side of the equation by using properties. Applications are calculations of different rates reaching the same distance or height. Vocabulary for this lesson is a review. Remember that a term is a number, a variable, or the product of a number and one or more variables. So for example, 3x, or even a product, 3ab. Like terms are terms that have exactly the same variable factors. So for example, 3x and 7x are like terms, or even 3xy, 7xy, and 3xy are like terms. However, 3xy and 7x are not like terms because they don't have exactly the same variable terms. Let's try solving some equations with variables on both sides. It's very similar to the idea of solving two-step equations here. We want to combine our like terms, and in this case we have the like terms of 3x and 9x. So how do we get the 3x over to the 9x side? Well, we want to basically get rid of it on the left side. And you know that when you get rid of a term, what you're doing is the inverse operation. So the inverse of a positive 3x would be just to subtract 3x. 3x minus 3x is 0. And so now it's gone from the left side. You have only 24 left. And 9x minus 3x is 6x. So you've combined the 9x and the negative 3x. And now you're down to a one-step equation. Divide both sides by 6, and x equals 4. Remember that in algebra you want to write your variable first. And remember that you can always check your answers by substituting. It might be a good idea to check the first few equations that you work with just to make sure that you're getting the right idea. Next we have a slightly longer equation, negative 7 minus 3x equals 1 plus 5x. So we want to get all the numbers to one side and all the variable terms to the other side. At this point you really could start with any step. I'm going to start with subtracting the 5x. So 5x minus 5x becomes 0, and on the left side I have negative 7 minus 8x equals 1. And now I'm going to move my negative 7 over to the right side to combine all the numbers, and the opposite of minus 7 is to add 7. So now I have negative 8x equals 8. And now lastly I'm going to divide by negative 8. And x equals negative 1. Now say you had begun this same equation by doing a different step. So perhaps here I wanted to add 3x because maybe you want to work with positive numbers more. So I'm adding 3x to both sides. So in the same idea, 3x minus 3x is going to cancel to 0, and you are still left with just negative 7. And 5x plus 3x is now 8x. And then to get the 1 to the left side, you're going to subtract 1, and you have negative 8 equals, goes to 0, 8x. And now we're going to divide both sides by 8. And you'll see that x still equals negative 1. So as long as you're using the properties of equality, adding and subtracting to the same to both sides, or multiplying and dividing to both sides, your answer will come out the same whether you begin with one step or another step. Let's try using the distributive property to set up an equation that we can solve. A biologist is growing 2 plants. Plant A grows 1.5 centimeters per day. The biologist plants plant B 1 day after he plants plant A. Plant B grows 2 centimeters per day. How many days after plant A was planted will the 2 plants be the same height? All right, so let's talk about what's going on in this problem. This biologist is growing 2 plants. He's growing plant A and plant B. If you notice, plant A grows at 1.5 centimeters per day. Plant B grows a little faster. It grows at 2 centimeters per day. And we want to see when are these 2 plants going to catch up in height. Well, They wouldn't catch up in height since plant B is always faster, except for the fact that the biologist planted plant B a day later. So he gave plant A a head start. So let's say D equals the number of days, because that's what we're looking for. We're looking for how many days. So we're going to say D represents the number of days that it will take for the two plants to catch up. Well, that means if they catch up, they're going to have the same height. So we can set them equal to each other, keeping in mind that plant B was planted a day later. So 1.5 centimeters per day times the number of days will equal 2.2, we could say 2.0 or just 2 centimeters per day. However, this time I'm going to say day minus 1 because the days, this one started a day later. Actually, it's going to be day plus 1 because this one started a day later. So now let's, we're going to minus 1 actually for this one because this is the total number of days, but this one didn't have the total number of days. It had one less day to grow. So we're going to go with minus 1 here. It had one less day. So 1.5 centimeters per day, the days are going to cancel. So we have 1.5 D equals 2D minus 1. I'm just taking out the units here, so it's a little easier to look at. We have 1.5 times D and 2 times D minus 1 in parentheses. So this is when I can set them equal to each other because the heights are going to catch up. And this is very important. I subtracted a day here because remember that the 2 centimeters had a day less to grow. So let's distribute 1.5D equals 2D minus 2. And now I'm going to subtract 2D from both sides. And 2 minus 1.5 is 0.5D, and it's going to be a negative equals negative 2. And now we're going to divide both sides by negative 0.5. Divide D equals, and I'm dividing 2 by 0.5, which I can't do with the decimal, so I'm going to move it once and move it once. 5 goes into 24, so D equals 4. So after 4 days, the two plants should catch up. Let's check it. Let's see if they'll have the same height. 1.5 for plant A times 4. 5 times 4 is 20. 4, 5, 6, and 1 decimal place. So it'll be up to 6 centimeters, plant A. And plant B, I'm going to be multiplying 2 centimeters times 3. Now, why am I multiplying by 3 instead of 4? Because remember that plant B was planted 1 day later. So it's only growing for 3 days. 2 times 3 is 6. So 6 centimeters for plant B. And do the numbers match? Yes, they do. So after 4 days, plant A will be 6 centimeters. And a day later, you plant B, and then it will also be 6 centimeters on the 4th day. So how many days after plant A was planted will the two plants be the same height? 4. 4 days. If this word problem was difficult for you to set up or difficult for you to answer, make sure you try the examples without the word problems first, because if you can understand how to solve the equations and be very familiar, you can start working backwards on how those equations were pieced together. And remember that you may have to read the word problem over several times to understand what the word problem is asking. Let's try another one. You run a half lap per minute. Your sister runs 2/3 laps per minute. Your sister starts running 5 minutes after you start. How long after you start running have you and your sister run the same number of laps? Okay, so you run at a rate of a half lap per minute. Your sister runs at a rate of 2/3 lap per minute. Okay, so the problem is, how could you catch up with your sister if you're running slower? Well, the reason why is because you get a head start. Your sister started 5 minutes after you. So I'm going to call M the number of minutes that you guys will catch up. So you're running at a half lap per minute, so a half times m equals, and then your sister is running at 2/3, but m minus 5. She gets less time. So let's distribute here. We have a half m equals 2m over 3 minus 10 over 3. I've distributed by multiplying to the top number. So now we need to combine the like terms. And I'm going to do that by subtracting 2/3 m from both sides. So now we have a half m minus 2/3 m, and I'm going to do that on the side. The bottoms can both become 6, so you would times 3 times 3, and you get 3m over 6, and here times 2, and you get 4m over 6. 3 minus 4 is negative 1/6 m equals, since this is canceled, negative 10 over 3. Now we need to divide both sides by negative 1/6. Those are going to cancel, and m equals. Now remember that this fraction bar represents a division. So basically what you're doing is dividing two fractions. And we're dividing by negative 1/6. So you always take the reciprocal of your second fraction. That's flipping it upside down. And now you have negative 10 times negative 6 is a positive 60 over 3, and that's 20. So how long after you start running have you and your sister run the same number of laps? Well, 20 minutes. You're starting, you get a total of 20 minutes, while your sister gets 5 minutes less. She gets 15 minutes. And so since she's running faster, she can catch up to you. All right, let's try some extra examples here. 21 plus 2t equals 36 plus 6 plus t. All right, so we have a number of terms on both sides, and we can combine our like terms. First, I'm going to start on the right side because I see 36 plus 6 can be taken care of. So 21 plus 2t equals 42 plus t. Now I'm going to move the t to the left side, subtract t, 21 plus t equals 42, and I'm going to subtract 21 from both sides, and t equals 21. Let's try an extra example with a decimal. We have 20.5 plus 3p equals 7.5p minus 26.5. So let's combine our like terms. I'm going to subtract 20.5 from both sides. This goes out to 0. I have 3p equals 7.5p. And the signs are the same, so I'm going to be adding 10, 7, and 4. So it's going to be negative 47. Now I'm going to subtract the 7.5p from both sides. And 7.5 minus 3 is negative 4.5p. This goes to 0, and I have negative 47. Now the opposite of dividing by multiplying by negative 4.5 is to divide by negative 4.5. So my answer goes to a positive, and I need to divide 47 by 4.5. That'll move once, so that'll move once. So 45 will go into 47 once, leaving me with 20. And I could make that into a fraction. So I could have 1 and 20 over 45, which will simplify to 1, and dividing the top and bottom by 5, 4 over 9. Let's try another example, solving an equation, and we're going to be using distributive property this time. So I have negative 5, 2c minus 8 equals negative 35c plus 5c. So I'm going to distribute this negative 5. We get negative 10c, and here we have to be very careful because we're distributing a negative. So a negative times a negative becomes a positive 40 equals, and then we can combine these. Negative 35 plus 5, signs are opposite, so you're going to subtract is negative 30c. Now we see that we can put together our C terms. I'm going to add 10C to both sides, and that cancels out to 0, and I have 40 equals negative 20C. I'm going to divide both sides by negative 20, and C equals negative 2. 40 divided by 20 is 2, and we have positive divided by a negative is a negative. Our last example here is going to be setting up an equation from a word problem. At the game store, a game rental costs $3.99. The cost of renting 3 games in one video is 11 cents less than the cost of renting 5 games. How much does renting a video cost? All right, so if I were going to rent 5 games, that would be 5 times $3.99. And if I were going to rent 3 games, that would be 3 times $3.99 plus the cost of a video rental. And that would be 11 cents less than the cost. So to bring me up to the same price as renting 5, I'm going to add the 11 cents that it would be less. Because remember, since we're setting an equation, we need both sides to be equal. The difference between the price is 11 cents, and the video rental and the 3 games is 11 cents less. So if I tack on the 11 cents, then they can both be equal on both sides. So now let's do our multiplication here. $3.99 times 5. You can think about it as 5 times $4, which is $20, subtract 5 cents. So it's going to be $19.95. That's using the distributive property from one of our previous lessons. So $19.95 equals, and then you can say 3 times $4 is $12. Subtract 3 cents would be $11.97, plus the video plus the 11 cents to make up the difference. Now I'm going to combine the $11.97 plus the 11 cents, and I'll have $19.95 equals, so we have $11.97 plus 11 cents, 8, 10, and that makes $12.08, plus the cost of the video. Now I'm going to subtract the $12.08 from both sides, leaving me with just the cost of the video. That goes to 0. I've isolated the V. 15 minus 8 is 7. I borrowed, so that's an 8. And then I didn't borrow again, so 9 minus 2 is 7. So $7.87. So the cost of renting the video would be $7.87. Let's go back and check our answer. The cost of renting 3 games and 1 video is 11 cents less than the cost of renting 5 games. So I'm going to say $3.99 times 3. 3 times 9 is 27. 27, 29, 9, 10, 11. So $11.97 is for the 3 games. And then we have the video for $7.87. That gives me 14. That's 17, 18, 7, 8, 9. That gets me to $19.84. And then let's add the difference of the 11 cents. That gets me 5, 9, and 19. So here we have matched it for the 5 games, $19.95 and $19.95. Let's go back and read the question. How much does renting a video cost? Renting a video costs $7.87. Thank you for watching educator.com.